Welcome back. We are moving right along. We're on lesson 4 in our first unit on solving absolute value equations. Your learning targets for this lesson are to be able to evaluate expressions that have absolute values in them and to solve absolute value equations. So, first of all, we need to talk about what an absolute value is. An absolute value of a number is basically the distance from 0 on a number line. Since our distances are never negative, they're always positive, the absolute value of a number is also non-negative or always positive. The symbol we give absolute value are these vertical lines, and we say that that represents the absolute value of a number x. When evaluating expressions, the absolute value bars act as grouping symbols. So that means that we do any operations inside the absolute values first before we do our evaluation. What I mean by that, here's an example. Say we have this equation we want to evaluate when x is negative 3. Well, first we substitute in the negative 3 everywhere there's the variable x, which is right here. And these absolute value bars are kind of like parentheses. They act as grouping symbols, so it says the stuff in here must be evaluated before you can do this addition. So when we do that, we get negative 15 minus 7, which is negative 22. And we know the absolute value of a negative number is always a positive number. So that gives us an answer of 23.4. So to solve absolute value equations, now this is super important that you understand. This is the most important part of this lesson right here. If you have an absolute value equal to a number, then you're going to have two cases. You're going to have this case or you're going to have this case. Okay? The way we're going to solve these is we're going to just drop the absolute value and solve it. A equals B. The other way we're going to do that is drop the absolute value on the left and say it's equal to the opposite of whatever the right-hand side is. Now the thing you need to notice is you have to isolate the absolute value first before you drop the absolute value symbol. Okay? So here's a simple example. It says solve this absolute value equation and check our solutions. We're always going to have two cases. So this is always when solving absolute value, because remember when we're solving absolute value, it's the distance on a number line. And the distance, you can always go to the left or to the right. That's why we have two cases. So the first case is where we say A equals B. The second case is where A is equal to the opposite of B. Well, A in this case is the left-hand side, or x minus 12 in the absolute value. B is 5. So to solve that, we're going to go ahead and drop the absolute value. X minus 12 equals 5. And then solving, we just add 12 to both sides and we get x equals 17. So now we need to check this. On the right-hand side, we used negative 5. Remember, it says the opposite of the right-hand side. And then drop your absolute value sign and solve. And we get x equals 7. Now what this tells us, let's go ahead and check it first. If we plug in 17 here for x, we get 17 minus 12, which is 5. And the absolute value of 5 is 5. That's true, right? Over on the right-hand side, 7 minus 12 is negative 5. And the absolute value of negative 5 is also wait a second. 7 minus 12 is negative 5. And the absolute value of negative 5 is not negative 5, it's positive 5, right? So this one gives us a false statement. So that's why we need to be checking our solutions. So one of our solutions is 7, the other one is 17, but we are getting a false solution here because the absolute value of negative 5, did I write that in here? X minus 12 is 5, right? The absolute value of negative 5 is not negative 5. It is definitely positive 5. So this would not be a solution right here. We would cross that one off. Since the absolute value of a number is always positive, when we get something like the absolute value equal to a negative, we say there's no solution. And here's an example of that. Remember I said you have to isolate the absolute value first, so we need to get rid of this negative 8. So we're going to subtract 8 from both sides. And this can never happen. When can the absolute value be negative? Never. So there's no solution. Whenever you see a negative on the right and you just have an absolute value on the left, it's no solution. So it's essential to check your solutions when solving absolute value equations. Even when we use the right procedure, the answers may not be actual solutions. We saw that in that last slide. That negative number was not true. So let's take a look at another example. It says to solve this, check our solution. Case 1 and case 2. So case 1, we just write it as it is. X plus 6 equals 3x minus 2. Case 2, we're going to write it x plus 6 is the opposite of 3x minus 2. And go ahead and solve those. This one, I would subtract x from both sides and then add 2 and divide by 2. On the right-hand side, we want to distribute that negative first. Okay, a negative 3x and minus a minus 2 is a plus 2. Then I would add 3x to both sides and then subtract 6 and divide by 4. Okay, so we have two solutions. Now let's check them out to see if they give us actual correct answers. Whoops, didn't mean to touch that one. So over on the left-hand side, we're going to plug in 4. We get the absolute value of 10 equal to 12 minus 2, which is true, right? On the right-hand side, we plug in a negative 1. So inside the absolute value, we get a positive 5, which is going to give us a positive 5. But on the right-hand side, we get negative 3 minus 2, which is negative 5. Not true. So that one is not a solution. So the only solution for this one is x equals 4. So that's it for this lesson. We'll see you in class.